Climate change poses significant threats to our planet, with rising temperatures, severe weather events, and devastating impacts on our ecosystem and human societies, demanding urgent attention and collective action worldwide. Hello everyone! We are the Group 2 reporters and we will be reporting the topic climate change. Here are the members of our group and their respective topics related to climate change. Our first reporter would be Josie Grace Lumanda, followed by Marisol Daming, then Charlene May Rodrigo, then Kalao Sheena, then Sahara Linonay, then lastly, Rosa Marie Pamatian. Again, this is our topic, climate change and carbon cycle. Here's the learning outcomes. By the end of this chapter, students will be able to, number 1, list the major carbon reservoirs on Earth and identify how carbon flows from one reservoir to another. The second, describe the ways in which humans are impacting multiple portions of the carbon cycle. Number 3, describe the causes and consequences of global climate change. Letter A, list the major greenhouse gases and identify their sources of impacts. Letter B, describe the effects of climate change on ecosystems. Letter C, evaluate the impacts of climate change from the viewpoint of diverse groups of people across the world. Number 4, identify methods of climate remediation, including carbon sequestration. Number 5, describe some of the research tools scientists use to study climate change. Now let's proceed to the first reporter, Miss Josie Grace Lumanda.
The carbon cycle, reservoirs and fluxes of importance and better understanding of the carbon cycle. What is the carbon cycle? The carbon cycle is the process by which carbon moves through the Earth's atmosphere, oceans, land, and living things. It includes the way carbon is stored in reservoirs and how it is moved through fluxes as photosynthesis, respiration, decomposition, and combustion. This cycle keeps carbon flowing and supports lives on Earth. Chemical symbol. The chemical symbol for carbon is C. In science, we use symbols from the periodic table to represent elements. C stands for carbon, a key building block of life found in plants, animals, air as carbon dioxide, and even rocks. A natural and continuous recycling. Carbon is neither created nor destroyed. It is constantly recycled in nature. It moves from plants to animals, from air to oceans, and even into the ground. This recycling happens all the time, helping keep the Earth's system in balance. There is no new carbon, only carbon being reused in different forms and places. Where does the carbon live? These places where carbon is stored are called reservoirs or pools. Some of these are the atmosphere, the air, oceans, living things, plants, animals, humans, soils, rocks, and fossil fuels. The movement of carbon from one place to another is called a flux. Think of a flux as the way carbon travels between places. Next is quick carbon moves or respiration. When animals, including us, breathe out carbon dioxide, we're helping carbon move from our bodies back into the air. This is called respiration, and it's one of the quickest fluxes in the carbon cycle. Plants, animals, and even bacteria all do this. Long-term carbon or fossil fuels. Some carbon is stored for millions of years. For example, fossil fuels like coal, oil, and gas are made from ancient plants and animals that were buried in chains under pressure and heat. Humans dig this up and burn them for energy, which releases that ancient carbon back into the air. The biggest carbon storage. So there are two largest places carbon is stored on Earth. These are the oceans. They hold the most carbon. And the lithosphere. That's a fancy word for Earth's crust. Rocks, soil, and sediments. So these areas store carbon for a long, long time. The power of plants or photosynthesis. Plants play a super important role in the carbon cycle. They take in carbon dioxide from the air and using sunlight turn into sugar through a process called photosynthesis. This sugar becomes part of plant's structure and energy source. This is how carbon enters the food chain. Plants are called primary producers because they make food and carbon compounds that animals can eat. You are what you eat. When you eat fruits, vegetables, meat, or any food, it all comes from plants or animals that got their carbon from plants. Our bodies use this carbon to grow, move, and breathe. This process is called cellular respiration, and it turns carbon from food into energy, water, and carbon dioxide, which we breathe out. So what happens when things die? When plants and animals die, decomposers like bacteria and fungi break them down. Some of the carbon goes back into the air, and some stays in the soil. In places without oxygen, decomposition is slower, and carbon can turn into gases like methane or hydrogen sulfide, some of which smell really bad. Combustion or burning biomass. When we burn wood or even fossil fuels, we release stored carbon quickly. This process is called combustion. You've seen this happen if you've ever had a campfire. Nature does this too. Lighting can start wildfires, which also release carbon. Carbon and the ocean. The ocean also plays a big part. It absorbs carbon from the air and uses it to support marine life. But there is a balance. Carbon dioxide goes into the ocean and also comes out of it. Today, this balance is not equal anymore because of human activities. Better understanding of the carbon cycle. Let's make this topic even clearer through a simple activity and real-life examples. Imagine this. You're a carbon atom. Okay, let's go on your adventure. You start in the atmosphere as carbon dioxide. A tree takes you through photosynthesis. Now you're part of a leaf. A caterpillar eats the leaf. You're now inside the caterpillar. A bird eats the caterpillar. You become part of the bird's body. The bird breathes. You're now back in the atmosphere. This is a mini carbon cycle. Carbon is always moving.
Human impacts on the carbon cycle. Climate change is primarily caused by burning of fossil fuel, leading to rising global temperatures and more frequent and intense weather events such as droughts, floods, heat waves, and storms. Developing countries, especially island nations and coastal areas, are practically vulnerable to these impacts, facing threats like sea level rise, and food insecurity. The Philippines is among the most at-risk countries due to its geographical location, making it highly exposed to typhoons and other natural disasters. Scientific evidence shows a significant increase in greenhouse gas emission, with the energy sector as the largest contributor. Graphs indicates the carbon dioxide levels have sharply risen since the Industrial Revolution, which correlates with the increase in global temperatures. Another chart highlights that electricity and the heat production, followed by the transportation and agriculture, are the major sources of emissions. The impacts of climate change include economic losses, damaged infrastructure, displacement of communities, and health issues. To address these challenges, both adaptation and mitigation strategies are necessary, such as transitioning to renewable energy, enhancing disaster preparedness, and reducing emissions. Global cooperation, scientific research, and immediate action are essential to combat climate change and secure a sustainable future for all.
Understanding what is causing global climate change. 1. Greenhouse gas emissions. Human-released greenhouse gases, carbon dioxide, methane, nitrous oxide, trap heat in the atmosphere. This is the primary cause of modern climate change. 2. Burning of fossil fuels. Coal, oil, and gas are burned from energy, releasing large amount of carbon dioxide. This contributes significantly to atmospheric warming. Deforestation. Deforestation, forest reduces the Earth's ability to absorb carbon dioxide. Deforestation also releases stored carbon into the atmosphere. Example of deforestation is illegal logging. Illegal logging is a significant problem in many countries, driven by high demand for timber and weak enforcement. Legal logging. Even legal logging can contribute to deforestation if not managed sustainably. Unsustainable logging practices can lead to forest degradation and loss. Industrial and agricultural emissions. Modern farming releases methane from livestock and nitrous oxide from fertilizers. These are potent greenhouse gases. Climate feedback loops. Warming causes Arctic ice to melt and permafrost to thaw, releasing more greenhouse gas. This amplifies climate change in a vicious way. Climate feedback loops are self-perpetuating processes within the Earth climate system where an initial change triggers a response that either amplifies positive or negative feedback. The initial change, understanding these loops, is crucial because they significantly influence the speed and extent of climate change. That's all. Thank you.
Greenhouse gases. These are the gases in the Earth's atmosphere that trap heat, contributing to the greenhouse effect. The four major categories of greenhouse gases are the following. Number one is the carbon dioxide. These are the gases emitted from fossil fuel combustion, deforestation, and various industrial processes. It is the most abundant greenhouse gas in the atmosphere. Next is the methane. Methane released from livestock digestion, rice paddies, landfills, and fossil fuel extraction. Nitrous oxide are the gases came from agricultural activities, especially fertilizer use, wastewater management, and combustion of organic matter. And the last is the synthetic fluorinated gases, including hydrofluorocarbons and sulfur hexafluoride. These are the synthetic gases used in industrial applications like refrigeration and in air conditioning. The table shows the lifespan of the greenhouse gases in the atmosphere. So, the carbon dioxide is variable in the atmosphere, and its potential global warming can last up to 1 year. Methane lifespan in the atmosphere is 12 years. Its potential global warming is 28 to 36 years. Nitrous oxide lifespan in the atmosphere is 114 years, and its potential global warming is the 298 years. Next is the hydrofluorocarbons. Hydrofluorocarbons can be at the atmosphere for 1 to 270 years. And it can contribute global warming for 12 to 14,800 years. Perfluorocarbons can last up to 2,600 to 50,000 years, and it can potentially contribute to global warming for 7,390 years. Sulfur hexafluoride can last up to 3,200 years and can potentially contribute to global warming for 22,800 years. Other climate change influencers are the following. First is the aerosols. The first picture at the upper right corner. Aerosols are tiny particles from volcanic eruptions, industrial emissions, and wildfires. Albedo effect. This is the changes in Earth's surface reflectivity. The second picture that you can see, ito yung pagbabago ng klima ng ating mundo. So may mga particles, yung white particles na parang snow, yan ang nagtatrap ng init, nagkakos or nakakadagdag ng global warming effect sa ating mundo. And the land use changes. Ito yung mga deforestation, urbanization, and agricultural expansion. So, di ba, kapag nagdi-deforestation tayo, nababawasan ang mga puno na nagko-contribute ng oxygen. So, kapag nababawasan ang mga puno, walang nag-a-absorb ng mga carbon dioxide. So, mas umiinit at saka yung sinusunog yung mga kahoy, mas nakakadagdag ng pag-init ng ating mundo. So, yun yung mga other factors na nakaka-influence ng global warming or climate change. So, next is we go to the tools scientists use to study climate change. So, the tool that the scientists used to study the climate change is called scientific model. This model is a projection of what might happen in the future based on knowledge of current and past events. So, ang mga scientists, nire-record nila yung mga data na nagagather nila from the past years at yung prediction para sa future, meron silang basihan. So, like this one, meron silang mga data na naitala. So, based on the data, na from 1900 up to year 2100 is even higher emissions scenario, yung the violet line. So nakikita natin na mas tumataas yung pag-init or yung pagbabago ng klima ng ating mundo. So sa kanilang scientific model, comparing climate projections with and without the influences of humans on greenhouse gas emissions. So itong data na pinipresent is pinapakita dito yung data na merong influence ng tao sa greenhouse emissions at yung walang influence ng tao sa greenhouse emissions. So, blue models using only natural forcings. So, yung line na blue, natural forcings yan. Yung pink, models using both natural and anthropogenic forcings. So, merong influence ng tao at natural. So, yung black line is other observation nila yan. So, sa makikita, the blue shaded band shows 5% to 95% confidence interval for 19 simulations from 5 climate models using only the natural forcing effects due to solar activity and volcanoes. The red shaded band shows the 5% to 95% confidential interval for 58 different simulations from 14 climate models using both natural and anthropogenic forces. So, mas bababa yung data ng only natural forcing. So, yung walang contribution ng tao, mas mababa yung climate change or yung temperature na na-gather nila. So, malaki, dahil sa data na ito, ipinakita na malaki ang impluensya ng tao sa greenhouse emissions. Ayun lang yung akin. Thank you.
Consequences of climate change. It explains the difference between global warming, which refers to the rise in Earth's average temperature due to greenhouse gases, and climate change, which includes a broader range of environmental changes. In addition to rising temperature, scientists have already observed changes in precipitation patterns, sea levels, and ocean acidity. Other expected impact includes changes in ice and snow cover, seasonal patterns, ecosystem, and habitats for plants and animals. Temperature and precipitation are two major effects of climate change. As greenhouse gases increase, the Earth's atmosphere warms and affects how much moisture the air can hold. Warmer air holds more water vapor, which can later fall as rain or snow when the air cools. As you can see, there are B1. B1, it means a low emission scenario, and A1B is a medium high emission scenario, and A2 is a high emission scenario. The scenarios come from IPCC or Special Report on Emission Scenarios. Global temperature are expected to rise throughout the 21st century under all emission scenarios. This temperature increase leads to more evaporation, which contribute to increased rainfall in some areas. However, not all regions will get winter some may face droughts. Cities like New York, Bogota, and Manila may receive more rain, while others like Delhi, Sao Paulo, or Los Angeles are expected to become drier. As you can see in the right area, blue areas project increase in precipitation while brown areas project decreases. Additional challenges may be felt by all areas of the world with regard to changes in the seasonality or timing of precipitation, as well as the form in which precipitation falls. Example, mist or downpour or rain, ice or snow. All of these factors affect the availability of soil water for plants, the flow of rivers and streams, and the overall accessibility of water worldwide. Furthermore, scientists predict an increase in the number and severity of storms and climate change progresses. Sea level rise. As you can see in the photo, this happens because glaciers are melting and warmer ocean expand. Glaciers from the past and present show how much ice has disappeared over the years. The shrinking of glaciers reduces the amount of available freshwater and contributes to sea level rise. Coastal areas and island nations are at greater risk of flooding as sea levels continue to rise. Millions of people around the world, especially in low-lying regions like Bangladesh and the Netherlands, face serious threats from these changes. Communities will need to prepare and adapt to protect their water supply, homes, and lives.
Hello everyone, I'm going to continue the report of Miss Sahara and the consequences of climate change. I'm going to report the last consequence which is ocean acidification. Ocean acidification. And when we say ocean acidification, it is referring to the decrease in pH levels of the ocean over time. It is caused by the absorption of excess carbon dioxide from the atmosphere. And this increase in acidity can harm marine life, especially those organisms with calcium carbonate shells, such as corals and shellfish. Alright? So, when we say carbon dioxide, how do you understand carbon dioxide? What do you know about carbon dioxide? Okay, when we say carbon dioxide, it is a colorless, odorless, and it is naturally present in Earth's atmosphere. Makikita natin yan sa atmosphere. And usually, it is produced by human activities such as pagsusunog or burning fossil fuels, deforestation. To understand more how carbon dioxides impact marine life, here's a simple illustration. This is carbon dioxide. Alright? Don't you know that there are more than 22 million tons of carbon dioxide absorbed by the ocean per day, every day. So just imagine how plenty, how huge carbon dioxide is absorbed by the ocean per day. So what will happen when this carbon dioxide is absorbed? Okay? What will happen then? The excess carbon dioxide dissolves into the ocean, where it reacts with water or hydrogen to create carbonic acid. And this chemical reaction increases the acidity of the ocean. Alright? So, mag-increase yung acidity ng dagat. And when the acidity is increased, something wrong will happen to the organisms sa ilalim. Alright? Ocean acidity is measured by pH. So, a lower pH, a higher acidity. So, kung low yung pH, power hydrogen, mas higher yung acidity. So, here's the formula. Hydrogen, carbon dioxide plus hydrogen is increase in acidity. So, what will happen when there's increase in acidity? Let's look at here. What will happen? Organisms with shells can't get enough carbonate ions to build their shells and can't maintain their shells or skeletons. So, maapektuhan talaga sila. So, kawawa yung mga organisms like shells, corals. Kawawa sila because of the excess carbon dioxide from the atmosphere thrown into the ocean. Let's look at number 3. Increased acidity harms marine life. Even small changes in pH can harm or can have a big impact. Some fish can't function well in higher acidity environments and may have trouble detecting predators, growing and developing, or finding suitable habitats. Acidity threatens plankton and other organisms that form the base of the food chain. This disruption of the food chain makes it harder for our larger organisms to get enough food. Marami talagang mga organism sa ilalim ng dagat ang maaapektuhan. Let's look at number 4. Humans who are dependent on marine resources are negatively affected. Many humans depend on the ocean for food or livelihood. Diba? Acidification impacts the marine ecosystem and makes it difficult for humans to get resources from the ocean. Halos lahat maapektuhan, hindi lang yung mga hayop sa ilalim ng dagat, pati na yung mga tao na naghahanap buhay sa dagat. And here's a simple illustration or example of pH level. Here's the example. Liquid drain cleaner. It has 14 pH level. So, meaning, hindi masyadong acidic. Another one, bleaches, oven cleaner, lye. It has 13.5 pH. Tingnan natin dito sa ilalim. So, ito, battery acid, hydrochloric acid. It has 0 pH. Ibig sabihin, mas mataas ang kanyang acidity. Because as what I said a while ago, the lower the pH, the higher the acidity. Alright? Carbon dioxide levels continue to increase. Many organisms, including the corals, that are the foundation species of the beautiful coral reefs, are very sensitive to changes in ocean pH. Scientists have documented cases of ecosystem destruction through coral bleaching caused by the effects of climate change, including ocean acidification and increased temperature. So this map shows changes in the aragonite saturation level of ocean surface. Okay, aragonite, when we say aragonite, it is a form of calcium carbonate that many marine animals use to build their skeletons and shells. A negative change represents a decrease in saturation. So, here's the negative change. This one, it represents decrease in saturation. Alright? Now, let's go to climate change solutions. May pwede pa bang gawin? May magagawa pa ba tayo to help this problem solved. All right. So, what are the solutions? While the situation surrounding global climate change is in serious and need of our attention, it is very important to realize that there are many scientists, many leaders, many concerned citizens or people are helping together to make a solution for this climate change as part of their life's work. So, they found two solutions. These are adaptation and mitigation. Adaptation and mitigation. So, how would we understand adaptation and mitigation? So, let's discuss it step by step. First is, let's discuss adaptation strategies. So, when we say adaptation strategies, it means that we must change our behaviors. It's us change our behaviors in response to the changing environment. Adaptations will vary greatly by region depending on the largest specific impacts in that area. Like this example, rain-limited cities near oceans such as Los Angeles, California. What they did is they chose to use desalination. This one, desalination. So when we say desalination, it is improvised drinking water to their citizens. Desalination involves taking the salt out of water, meaning here, the ocean, taking the salt out of this water. This is salt area, and they are using machines to make it potable, to make it fresh for their drinking. Alright, that is desalination. And that is the example of adaptation. So let's go to another strategy, which is mitigation. When we say mitigation strategies, it is referring to efforts reducing greenhouse gas emissions to limit global warming. So that is mitigation. In general, a strategy to mitigate climate change is one that reduces the amount of greenhouse gases in the atmosphere or prevents additional emissions. Mitigation strategies attempt to fix problems caused by climate change. Alright? So, governmental strategies. So, here's a solution. Fuel efficiency regulations for vehicle. Diba? So, another one, carbon taxes or charges implemented in our country like India, Japan, and UK. So, how about technological strategies under mitigation strategy? Carbon capture and sequestration, or CCS. Captures 80 to 90% of carbon dioxide emissions from sources like coal-fired power plants. Stores carbon dioxide deep underground in porous rock formations. So that is under technological strategy, under mitigation. So this picture, carbon capture and sequestration schematic with landmarks shown to scale for depth reference. Here's the picture, here's the power plant, the injection well. Alright? Scientists are also looking into the use of soils and vegetation for carbon storage potential. Okay, proper management of soil and forest ecosystems has been shown to create additional carbon sinks for atmospheric carbon, reducing the overall atmospheric carbon dioxide burden. Increasing soil carbon dioxide, carbon further benefits communities by improving better quality soil for agriculture and cultivation. And this is the example of mitigation strategy, the carbon storage. Okay, another one in technology related to alternative energy sources. Mitigate climate change by providing people with energy not derived from the combustion of fossil fuels. So, like this one, the wind power energy, bioenergy, geothermal energy power, solar energy, or hydro power. Okay, that's another example of mitigation strategy. Another one. Finally, simple activities such as conservation, choosing to walk or bike instead of driving, and disposing of waste properly are activities that, when done by large numbers of people, actively mitigate climate change by preventing emissions. Ito, no? These are the examples of mitigation. Choose green vehicles. Use public transportation instead of bringing your own car. No, just use transportation. Public transportation. Ride sharing. Alright? Walk instead of using car or motorcycle. Just walk or use bicycle. By doing this, we may be able to help the problem of climate change. Now, in reflection, did you know that the ocean pH has changed from 8.2 to 8.1 since the Industrial Revolution, resulting in 30% increase in acidity? It looks like so small, 8.2 to 8.1, but it is 30% in the overall total of the acidity. So, increase in acidity in our environment, especially in our ocean. So, here's the reflection question. Take a moment to identify ways that you personally can be involved in mitigation or of adaptation to climate change. What changes can you make in your own life to prevent excess carbon emission? So here's the example of mitigation and the adaptation. So think about what ways you can personally involved through mitigation or adaptation. Which are these activities? Which activities? Now, in conclusion, addressing climate change requires multifaceted approach combining scientific knowledge, technology innovation, and global cooperation to reduce greenhouse emissions and adapt to its far-reaching consequences, ultimately ensuring a livable future for generations to come. This collective effort demands immediate action, informed decision-making, and shared responsibility to protect the planet's ecosystem and natural resources. And that's the end of our report about climate change and carbon cycle. Thank you very much for watching.